In this question, we're going to rely on our knowledge of the acceleration due to gravity. When an object is falling freely through the air, that means it's not being acted on by anything else other than the Earth pulling it towards it. The acceleration due to gravity is 9.8 meters per second squared, or 9.8 meters per second per second. What this means is when the wrench is in the worker's hands, it's not moving. And then as he drops it, a second later, it'll be going at a speed of 9.8 meters per second. A second after that, it's going to add 9.8 meters per second again. So it's traveling with a speed of 19.6 meters per second, and so on and so on. So as it falls, it's gaining speed. So what the question is asking for is what speed is it going when it says when it hits the ground, you might think when it hits the ground, you might think the answer is 0 because when it hits the ground, it comes to rest. But what this actually means is when it hits the ground really means the instant before it hits. So what we're saying is imagine the ground wasn't there and it's like the instant that wrench is just about to touch the ground, that's what we want. That's where the final velocity is. So its initial velocity v naught equals 0. Its final velocity is what we're asked to find. We know that it's accelerating, so I'm going to put an a, which is in this case g, equals 9.8 meters per second squared. All right, and we also know that this building is 80 meters high. So we can put that in. So listing all of our variables the way we did before, delta x, delta t, v naught, v and a. Listing all the things we know 80 meters for the distance it falls. We know that the initial speed is 0. We know, its acceleration due to gravity is 9.8 meters per second squared. I want you to notice here that without actually explicitly doing it, I've actually created a sign convention. What I've assumed by the numbers I did in here is that down is positive and up is negative. So basically what I'm saying is the downward direction is positive. And that makes sense because my acceleration is down, so it's accelerating downwards, so that's a positive, and it falls downwards. This 80 meters is actually, when you think about it, it's falling down. So that's also positive. So without really meaning to, because everything's moving in one direction, I have it that down is positive, and it makes sense. So sometimes you will choose a sign convention unintentionally, and in this case, we made down positive. The question is asking me for the velocity, so this is what we're being asked to find. So in this case, my don't know, don't care is time. So going back to the equation sheet that we had here, if don't know, don't care is time, then this is the equation I'm going to use. So v squared equals v naught squared plus 2a delta x. So then I will write that down. V squared equals v naught squared plus 2a delta x. And we can just solve this. So v squared equals 0 plus 2 times 9.8. Remember, a is 9.8, which is g, times 80. Okay, so then solving this, v, we get the answer of 39.6 meters per second. So when I solve this, really when you do this, you take the square root of both sides, right? And when you do that, technically the answer works out to plus or minus 39.6. But since we know it's moving downwards, at the instant it hits the ground, it's moving down, we are going to choose the positive. The negative is inadmissible in this problem. So so it's asking actually for the velocity, which is 39.6 meters per second, and since it's a velocity, it needs a direction down. And that is our answer to this problem.